Welcome to another episode of Code for Thought. Happy New Year, all the best for 2023 and welcome to another season of Code for Thought. It's going to be quite a busy season, including the new bite-sized RSE sessions in collaboration with the Universe HPC project, and I do hope you'll tune in. So let's get started and kick this season off with a conversation I had last year with Nicolas Thiery in Paris. Nicolas is an open science activist and has been working lately to use open source tools in teaching, in particular Jupyter. In our conversation he explains how the pandemic accelerated the use of Jupyter in the classroom, and he is leading the Candyce project in France to explore and promote the use of Jupyter in teaching. I think Nicolas makes a compelling point about why it is important to use open source tools like Jupyter in education software, and right at the end he argues for education software engineers to bring more and better tools to the classroom. And here now my conversation with Nicolas. Hello Nicolas, thank you very much for your time today.
You're very welcome.
And thank you for arranging this room. This is the first time I'm in the École Normale Supérieure. I hope I pronounced that correctly.
That was perfect.
Thank you. So we're here in Paris to talk about open science and also Jupyter Notebook in education and in the classroom. But before we do that, maybe you can introduce yourself quickly.
So I am Nicolas Thiery. I'm a researcher and teaching at Uni Paris-Saclay in computer science. I've been using computers and playing with computers for 40 years now, and I must say enjoying it. Yet at the same time, I wouldn't call myself a technology fan. It's more that I like collaboration. Computers have very different skill sets, so which brings interesting venues for collaborations. How to use the fact that they are very powerful, yet perfectly stupid, and how can we make it so that we best combine both of them to best achieve the targets, the task that we have at hand. And now the question, of course, is how we define best. Question of efficiency, there is a question of being fun for humans, questions of good resource usage of resources, of course, with environment behind the scene and all these things.
There's quite a lot to talk about because when you talk about collaboration, for instance, yes, computers can enhance collaboration, but very often you're basically stuck in front of a screen which is not particularly collaborative. I think there's technology that can help collaboration and there's technology that actually can hinder it.
Yeah. And here it's very much about how to collaborate with the computer, how to best use the computer to do the boring parts or the parts that need actually a human to think about it, and how to keep control.
You're an open software activist and also working to make Jupyter available in the classroom. And I would be really interested in how it all started.
All right. So open source activists goes really back to what I said just before, keeping control and making sure that the computer is helping me and not helping itself, which it doesn't know what it means, or helping someone else. And open source is one of the bricks to get there, to keep this control. And also to, of course, promote collaboration between humans, having as many people bring different eyes to improve the software.
And how did you get into all of this? So what is the history there?
Actually, my father, a long time ago, did say a few words about the importance of being able to see the code, and then I completely forgot about it. 10 years later, I read the manifesto of GNU Emacs and the GNU manifesto by Stallman. That's really made a tick on this. Okay, yes, there are ways to collaborate on software and to share and to find good models to do software development. And this pinged me to be an activist in open source on one hand. And then about the same time, I started my career as researcher and as teacher. Of course, very soon I wanted to bring the two together. So how to put computers to good use for research, how to promote open source in these computings. Also in teaching, and lately is the teaching part that has been kind of taking over a lot of my energy.
So Jupyter Notebook has been used for quite some time now. And it's been used in the classroom for how long do you think?
Well, it depends if you speak about Jupyter notebooks or notebooks. My first contact with notebooks dates back from 1994 with Maple.
Oh, okay. Okay.
And I did use notebooks for teaching very soon when I started to teach, I believe, in 1997. So the concept of being able to write documents where you can have combination of narrative text and computations and visualization all in the same place, so that the student doesn't have to jump from one tool to the other, but just be able to follow a narrative and be able to, with pieces where you can interact, try examples, not only try them, but actually change them and explore. So that's something that's been used for quite some time. What's really new with Jupyter is Jupyter. Before you had the Mathematica notebook, the Maple notebook, the Sage notebook. So you had as many interfaces, and whenever someone had to change from one tool to the other, you had to relearn a new interface. Here there is really this new thing with Jupyter to try to make a unique interface that follows standards and that is as integrated as possible with many different languages. So Jupyter is for Julia, Python, R, but actually it's something like 50 different languages, and I myself use it also for C++ programming, interactive C++ programming for my freshman students, or even for complete beginners. So I was using it not intensively until 5 years ago, yes, even 6 years ago. And then with Jupyter coming in front and with the possibility to do interactive C++, with colleagues, we made an experiment to actually use it for complete introduction to programming. So really students that were arriving at absolutely no programming background. For them, having Jupyter notebooks was very nice, because usually in a programming class, you have to learn, you have the text editor on one hand, you have where you execute your code, and then you have your class notes, and the student has to jump from one to the other. Whenever the student wants to try something, he will have the consequence of what he did maybe 1 minute later, and that's already too late. Here you can really write a document, and with the very first programming where you just need one line of code, you can just put that line of code, the student tries it, has immediate feedback, try again, change it. So you have this very quick interactive loop with as little context as possible outside of what you are trying to teach him, and that's very nice for introductory programming. So progressively we developed a one semester course where about 2/3 of the course are based on really Jupyter notebooks. And then as students grow up and start writing larger piece of codes, then we switch to a more usual workflow where they will write the program in a text processor that is designed for programming, and then possibly use it from Jupyter or use it from other places.
Right, yeah. Now I was about to ask how that works with larger pieces of code, or when you actually work on a module or a library where you have different files to manage.
So the way I see it is that Jupyter, in some sense, it's like a sheet of paper. You can do a lot of things on a sheet of paper. You can scribble, you can draw diagrams, you can do pictures, you can write text. We are actually trained. If you put a young student in front of a sheet of paper, he's not going to make a good use of it. We are being trained to write essays and to structure the document in a very specific way. And the same thing for Jupyter notebooks. It's super flexible, and thereby we need to train our students. If we just let them go, they are going to use it, and then very soon they will be abusing it. A very important part is actually to train them for good use of the tool. And one of them is to not abuse it, not use it as a code editor, which it's not. Whenever the programming starts to be larger, whenever the core is not so much anymore about the interaction between the narration, the programming, and the computation, then start using different tools for all of them. And in particular, using coding tools for writing the code, and then focus in the notebook about the narrative part where you are going to explain, where you are going to tell a story. Here is how you use the code, and from this library, you can do this and do this, but the code is hidden because that's not part of the narration, unless it is part of the narration, and then it should be shown.
So when we talk about classroom, we're talking about computer science students or...
That's a very good question. So the class I was mentioning just before it's a curriculum which is about math and computer science, but many students come here with no computer science background. So we start from zero, and then we go very fast. This course is really a course focused on programming. And Jupyter is very nice for the beginning. For more advanced programming courses, probably I would be using different tools. And then where we're using it more is for computational courses. So course where you do computation. Of course, to do computation at some point or the other, you will do some programming, but the core is not on programming, it's on using the code. And so we have data science courses, we have science about numerical analysis, and so in Paris-Saclay, and of course in many other places, Jupyter is used in a lot of different classes for biologists, physicists, mathematicians. Yes, I'm using it a lot in my math classes, and it's broadening.
Yeah, because we had just before this interview an interesting discussion with people who actually work here at the École Normale Supérieure in archaeology, I believe, and certainly humanities and both. And they require some software skills and technology skills as well. So do you see that expanding? Or do you see a need that we actually need to teach people to program, not just what you just mentioned, physicists, biologists, etc., and computer scientists, obviously, but also archaeologists and linguists, etc.
So I'm certainly not an expert, so it's just witnessing from far away. But yeah, I do see in the computer being used more and more. More and more, you get computer used by people that are really not computer experts. So we need tools that allow to blend the two together, that makes technology as easy as possible for people outside. And that's one of the places where the concept of notebooks, where you can mix narratives and computation, is very handy, because you can, with the narrative, you can guide newcomers and point them to specific points that they should be manipulating and hide the details. And then progressively, you can reveal them. You give them the power to actually look at how it was done, maybe because they are curious and they want to know what method was used. But also, it will be, oh, this is almost doing what I want, but not quite. Maybe I can change this little parameter. Or maybe it can go a bit deeper and then start changing a little line of code or combine two tools together. In this community, you can have each actor of the community progressively gain expertise and go deeper and deeper as needed. And that's really the combination of open source, which enable collaborative works between people, and the notebook has this very specific role of bringing them together in a ground where you can be as close to the beginner as needed or as close to the hardcore as needed.
I think that's quite an interesting way of doing it, to have kind of an easy way in with Jupyter Notebook, where a lot of that is hidden. Because in another interview that I had recently, somebody said that a lot of that is particularly in fields that are not a kind of computer oriented right from the beginning, like computer science, right? People may have a fear of touching, oh, this is too complicated, oh, I don't really like this. Do you see that Jupyter Notebook can help here sort of take that fear away and sort of help people?
Yeah, the entry barrier is the key. So usually it's done by having dedicated software. And then so you have dedicated software for newcomers. But then you lock, with the strategy, you lock your newcomers in those, and then you make a complete barrier. On one hand, you have users. On the other hand, you have developers. And you don't have this freedom to move between the two. What notebooks bring, this ability to go as close as possible from easy to use interfaces, but then without locking people there and giving them the power to progressively go further and reach developers.
I would like to change the subject just slightly, because we obviously have had a pandemic recently, since 2020. For 2 years. We all hope it's over now, but
crossing fingers.
Crossing fingers. But how do you think that changed how computers or Jupyter Notebook, or in fact what you've been doing in the classroom?
It changed two things. Well, first, it put a sense of emergency, which means that many people got to invest a lot of energy to solve the problem that students were facing. Students were facing two things. The first thing was just the plain access to the software. Beforehand, most of the time they were coming to the university and using the computer labs and working in the computer labs. By chance, 2 years before the pandemic, we had started to launch a Jupyter Hub service, precisely so that students could work from home more easily. We had noticed that this entry barrier meant that the good students, for them it was easy to install software, so they were working at home, and the students for whom it was more difficult also had trouble installing the software and therefore did not work at home and therefore were even more and more in trouble. So we had deployed this Jupyter Hub for use at home. And we were very happy to have done this at the pandemic stage, because this meant that the first day of the pandemic, we had a reasonable solution for our students to work from home and have access to all the software. Of course, we had to work a bit to scaling, because it was meant to have 20 people. When we had 20 students working simultaneously from home, we were quite happy. Here we jumped to 100 or hundreds of students working together. So it was a bit of work. But at least the tool was there. And so this really meant that from the day to the next, we were able to switch and have all students keep working and have access to all software. So that was nice. Now, that was not the end of the story because the interaction with the teacher is much harder remotely. So we tried all different possible combinations. And for me, the combination that works best was by producing Jupyter notebooks that contain everything. So essentially what I took was all my course notes and made them into Jupyter notebooks so that students could go through them on their own instead of listening to me while I was doing it. And I switched to essentially some form of flipped classroom where they would be working on the material by themselves, and I was there to answer questions. And so instead of lecturing them for 1 hour, I would be just there for 2 hours and just answer to their question on the flow as it was going. So there, having the Jupyter notebook format where I could have lecture notes that were easy to follow and completely linear. As a teacher, I spend my time switching from my text editor and my slides and my compiler and etc. So that's fine for me because I know what I'm doing. But for the student to reproduce it by himself, it would be very hard. Whereas with the Jupyter notebook, it's just a linear narrative and it just follows a linear narrative.
Do you see that actually changing the classroom permanently? The way we teach has gradually changed because we introduced new technologies. But as you say, COVID accelerated that massively because everybody suddenly was, of course, at home and working and studying from home. Do you see there's a chance and an opportunity to actually change the way we teach in future?
I'm not going to speak for all different areas because things can be really different from one domain to the other. But definitely in my area, so teaching computation and teaching programming, it goes with something we had been facing for a long time, is that we have students with very different backgrounds on one hand, and also we have students that have different constraints, particularly the format of having courses that are defined at a very specific time in the year, following a curriculum, where we see them every week at a different given time. This is necessary because putting people in front of MOOCs, well, we know what we do with MOOCs. We start them, we work on them, and most of the time we just get lazy. It's hard without this guidance. So it's important to keep, and we still need a teacher to be there to have this synchronized flow where you bring students from one time to the other. But you have students that are sick, you have students that arrive late, you have students that have visa problem, you have pandemics, you have many different reasons why students may not be able to attend those. Or also you have students from other curriculum, and their curriculum is basically full, so it's not possible in the curriculum to add computer science classes. But maybe in those curriculum you have 2-3 students that are very good, very fast, have some free time, and this free time we would be interested into following courses. The direction we are aiming at is keep these structured courses, but try to write them in a way so that students can be as autonomous as possible to follow them, as much outside of class or in class, but this is also very useful in class. So what we noticed when we switched to Jupyter notebooks is that this made our students, even in class, our students were much more autonomous, which means that instead of spending our time answering questions to many of them, we had far less questions. Usually, most of the students would just ask one question here and there, and actually interesting questions. But then we had a lot of free time. This free time we could focus on these students that this particular day were fragile on this particular topic. Because of this, even with 30 students in my computer labs sessions, I've been able to decide, okay, today I'm going to spend 20 minutes with this student and sit next to him and just devote all my time to unlock him at his given point. And this is really giving autonomy to the student because he has a narrative structure that he can follow and where he's already guided and has, in principle, all the material. Of course, there is always this specific thing that is missing for this specific student, but for most of the time, we can just follow along and read from there.
It's more effective to actually help them and guide them than... okay. I would like to ask you about Candyce, because that's a project that you're involved with, isn't it? Could you explain a little bit about what that is?
So what is Candyce about? So it's been, as we already discussed, Jupyter has been used more and more in the classroom. There's been really a bottom-up movement. Teachers discovering this tool, writing notes, sharing expertise with each other. And because there was a need to ease access to these tools, many universities or other entities did deploy Jupyter hubs, so infrastructure so that students could use software. So there is this bottom-up movement on one hand. Then there came another consequence of COVID is that there was recovery plans. And so money somehow pouring down. Some people in particular at INREA. INREA is one of the main institute for research in computer science.
Okay, here in France. Okay.
So INRIA received a mission from the state to think about how money could be used to enhance use of computers for teaching. We thought that, maybe that would be a good occasion to support this bottom-up movement of using Jupyter, of using notebooks in general for teaching. And so we decided to focus 10 million euros on using notebooks in teaching. And so then the question is, it's a massive amount of money, and what can be a good use of it? Use number one is to put the technology at the fingertips of people. And so deploying infrastructure so that everyone, so of course you need to define everyone, but everyone has access to the structure. Providing access to computer resources to everyone on Earth would be expensive. If you think about anyone doing serious artificial intelligence, there will be use of GPUs, costly resources. So it cannot be everyone. So here the idea is to deploy an infrastructure so that the tools would be accessible for simple uses, not too expensive in terms of resources, basically, for every student and teachers in lower education and higher education in France, which is already a fairly large scope.
That is quite, because how do you deploy then the infrastructure? Not centralized. There isn't one massive Jupyter hub for every school or every university in France. Or how do you deploy that? How can we?
So it will be actually mixed. So the main server will be centralized, but running on some cloud service in France, so meant to be scalable. One of the technology that will be used will be Jupyter Lite. Jupyter Lite is a version of Jupyter where everything happens in the browser. When you use Jupyter, you use it from your browser. All the user interface all the manipulation that you do actually happen locally inside your browser, so on your computer. But usually the computation itself happens in a central server. And then, of course, this brings the thing that this central server will be using a lot of resources and makes it harder. So Jupyter Lite allows to do the same, but with the computation actually running in the browser itself. So actually, a person would be using his own resources. What we bring is easy deployment of the software, plus centralized storage of data for backups, for collaboration, and so on. So that will be one of the usage, and we very much hope that this will be reducing usage of resources. But of course, there are cases where some software are too big or too complicated to actually run in the browser. So in complement of this, there will be also centralized computation. So from the technical side, the work will involve different aspects. There is this aspect of scaling. So in the Jupyter ecosystem, there are already a lot of tools to deploy services. And so it will be enhancing those services so that they scale to high availability. That will be interesting challenges there. So that's part of the work. But then actually most of the work and most of the development work will be more about how to improve Jupyter specifically for teaching. We'll be targeting students possibly in high school or even in lower grades. And there you can afford to have user interfaces that are good for researchers, but not so simple to use for beginners. Of the different areas, there is simplifying the user interfaces, doing actually UX experiments and involving UX experts to improve them. Also work on accessibility to face all of the different challenges for people that are blind, etc. So making this tool as accessible to everyone. And then there will be tasks which will be more focused on teaching themselves. Things like how to make it easy for the teacher to be able to look over the shoulder of his students, to distribute content and get back the result from the student, how to grade. And then there will be also a lot of work. And this part is not defined yet because it's work that we want to co-construct with teachers, is about doing tools for teaching, really tools dedicated to teaching. So kind of thing we are thinking is, since we are mentioning before archaeology or geography, we could imagine having interactive maps with computation behind the scene. And so we need to construct those tools so that a student could have interesting interactive maps where he could explore the world and find specific information that would be related to and relevant to the course that is learning at a given point.
Jupyter is open source, so you could contribute to the improvement of the UX. So how do you go about it? What is your plan there?
Very much so. So we have this official mission, this let's say primary mission, to deploy this infrastructure. But we put as secondary mission that infrastructure for France, okay, it's nice, but will be much better if what we do actually is useful for everyone. So the plan is that all the development that we do will be contributed upstream. so that it improves the Jupyter ecosystem and so that others can deploy similar infrastructure. So every line of code will be open source and contributed back to the Jupyter ecosystem. To achieve this, one of the early decision was to lean on core Jupyter developers that have strong experience with this. Most of the development will be done by QuantStack, which is a French company which hosts many of the core Jupyter developers and have a very strong experience on how to contribute upstream and how to improve the Jupyter ecosystem each time they have a given mission.
There is one dimension that I would like to touch on, which you alluded to earlier, and that's the teaching aspect. So giving teachers the tools, but also convincing teachers to use it, because there probably is still a trend, or at least in some places, to do it the traditional way without Jupyter Notebook. How do you get them on board?
That's a very good point. We spoke a lot about the technical side, but actually the technical side is only 1/3 of the budget. A lot of the work beyond that will be how to support teachers in using the technology in lower education, in higher education, but also making contacts with the research. So there will be researchers in education that will be involved to study, for example, how Jupyter is used, what Jupyter can bring, so to evaluate the project. But research will also be involved, because since we will have a centralized infrastructure, we'll be in capacity of collecting data. And so the idea will be first research on how can we make good use of data for the users themselves, for research, for all the different actors, while preserving privacy and respect of users. Being able to combine making a good use of the data while preserving privacy is a research topic by itself.
It's a challenge, yes.
Yes. But then there will also be using this data for research and being able to watch how cohorts of students grab the tool, whether it's actually useful, and have actual metrics to base decisions. In terms of how to support teachers, so there will be a variety of actions. Some of the actions will be simply to disseminate through conferences, workshops, attending regular workshops about teaching and using computers for teaching that are existing, and then going there and presenting what Jupyter inspire people by showing them interesting things. First step, inspire. So inspire them by showing them, inspiring them by producing resources that are interesting. In many areas, there are already interesting resources that exist. For example, in archaeology, or areas like this, where Jupyter is already used in research, but not yet in teaching. What will be interesting is to start from those research resources and make them into inspiring teaching resources, so that teachers seeing them say, oh, I could make something, I could use this tool in my class. And then we hope that then teachers would be using it maybe in higher education, which is as very close from research, and then that progressively it would percolate. So most of the work is really to help this percolation, so that usage in research progressively go into usage in higher education and possibly go down into lower education.
It's quite right that you point out that we start with universities, but your hope is that it will then go into the schools.
Yes.
I mean, that sounds like a monumental task, and I know that 10 million euros sounds like a lot of money, but how long do you think you will have for this project?
So actually, 2 years from now, you would have asked me, is Jupyter used for high schools? I would have thought, I'm teaching to first-year students. Well, not that different from high school students, so maybe yes. So I could infer that yes, there was a possibility, but I wouldn't have invested 10 million euros just on this bet. What made me change my mind is that people at Académie de Paris have deployed a Jupyter hub for teaching in high schools. So they started the project 2 years ago, and nowadays they have 200,000 students using it.
200,000?
Yes.
Well, that's a large number.
Which means that there is actually a need, that it fits a need. Is this a perfect tool? How can it be improved? Can it go further? That's a very good question, but there is something to start from. So one of the reasons for this is that in the last couple of years, we have introduced quite some computer science in high schools. So this tool has been targeting particularly computer science students learning computer science. It's not a top-down that just drop, here is this cool tool, you should be using it. There is already a movement trying to use the resources to accelerate the movement. And then engaging the community through training, through identifying ambassadors that would be interested in using the tools and developing resources share them with colleagues. So it's very much about using the existing community there to let the tools spread. One of the key aspects here will be to develop a library of Jupyter, let's say notebooks, of resources, design resources, can share them so that they are easy to discover. And here we are exactly meeting the FAIR IDs so that they would be findable, accessible, interoperable, and reusable. So this is very much about open science at the end.
The final question that I have is, how can people actually contribute, since it is open science, since it is open software?
Interesting point. And here we should not be thinking Candyce. Candyce will some contribution to the Jupyter ecosystem, which is much wider. So best contribution is just to use the tool and report whenever things are not working as smoothly as they could. Writing resources, sharing resources with other, going down to not only write resources itself, text and examples, but maybe write a small application that you can embed into a notebook and share it with others, and progressively go down deeper and deeper. For Candyce itself, use it, spread the word, and bring back reports.
Okay.
No, one thing we're very much interested in, especially in international setup, is so currently we're focusing in solving the problem for France, which is already an interesting challenge. But then, of course, we would want this to be useful in a larger setting. Identifying other countries or other areas in education where people would want to deploy infrastructure like this or use tools and collaborate together for this would be very interesting. So the project itself is 3 years. So that's for the initial setup. One of the main motivation for these 3 years is to plan for the future. If everything goes well, there will be sequels. And these sequels maybe will be French-wide, or maybe they'll be European-wide or larger. Yeah, it's all about open source and joining forces with whoever has similar needs that we want to tackle.
So at the end of these 3 years, how do you then prove that you've been successful? That's a mean question, isn't it?
It all boils down, is it used and how is it used? Now, of course, comes the things of how do you measure usage and how do you measure useful usage? If it's used, but it's not interesting for teaching or bringing people to waste a lot of time playing with computers rather than learning, then it's a waste of time. That's one of the reasons why we want to have researchers on board so that we actually will be able to evaluate how many users, but more finer, what does it actually bring to education.
Okay, well, thank you very much, Nicolas. That was a very interesting interview. I wish you all the best for Jupyter, Candyce, and bringing computing to the classroom.
Thank you. And maybe if I may add, since we are very much related to the research software engineers,
right?
I would advocate for education software engineers, because we are facing exactly the same problem with education, where we not only need to have support to help tools, but we need actually support to develop the tools. This is very similar to what happened for research. We need people that do participate to the design, development of software that is specifically useful for teaching.
Well, thank you very much for highlighting that. And I think that's a very good call because, yes, you're right. There is, of course, commercial software out there, or some of it at least, but then we get exactly the same problem that you described earlier, that people have to switch between different vendors. There's lock-in, it's very expensive and not particularly useful in the long run in the actual workflow of students. Well, I hope that the listeners will take this on board. Cheers, Nicolas.
Thank you.
Bye now. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.